So we have a lesson on density. We'll try a few problems from the pages, let's see, it looks like 19 to 21 in the packet. So we'll start out with number 1. There's a couple ways to do these kinds. The way we're going to choose to do them is using proportions, typically. All right, not always, but we're going to change units of measure using proportions. Some people use dimensional analysis, which is a good idea, but we're using proportions because so many of the concepts will be using proportions, similarity, things like that. So it makes a lot of sense for us to teach you one concept and use it for many topics. So that's what we're going to do. Okay, so big thing on these questions is read it a couple of times. And so we have to read and reread. 2 or 3 times, maybe more. Now, what we really got to do is focus on units of measure. What that's going to do for us is it's going to tell us how to set up the proportion. And I'll show you what I mean by that in a minute here. So what we have is, we read it, a hot air balloon holds 74,000 cubic meters of helium. Don't worry about a very noble gas, with a density of 0.1785 kilograms per cubic meter. How many kilograms do we need? Now, right away, this is something we've got to teach students to convert, okay? Here's what this means. The per is kind of like division. So what I would write it as is I would take that number and I'd write it as 0.1785 kilograms. And then underneath it, I would put 1 cubic meter, or meter cubed. We write it like that. So now here's how we finish it. We want to know how many kilograms of helium does the balloon contain. Now ready? So here's our density given to us. Okay. Now if you're in science class, you do this differently, but we're in math. And then what we're going to do is we're going to take care of the balloon's dimensions here. So in the balloon, there's 74,000 cubic meters of helium. You're going to line that up underneath because you're just going to keep consistency with your units of measure. Okay, here's cubic meters underneath here, so let's be consistent with our space. Okay, another way some people look at density is stuff over space, and that's good too. Okay, your cubic meters is the space, but that's not always going to work. So let's keep going here. How many kilograms? We don't know. We tend to call it X. Okay, now for a minute, I'm going to take a liberty to not keep the units of measure coming along. Science wouldn't like that, but we'll come back to the units of measure. So we cross multiply. So I'm just going to ignore the, I'm going to ignore the units of measure for a minute. So it's 1x, and then the equal sign, and whatever 0.1785 times 74,000 is. Okay, so x is going to happen to equal 13209, and then that is kilograms. Okay, so that's that one. Second one, or number 3, we're going to skip number 2 for now and just go right to number 3. So read it. We've got a Wisconsin-based dairy farm, has 1,200 cows in their milking herd that collectively produce that much milk. Okay, so last year I did this problem, and they thought each cow produced that much milk. So collectively, so the 1,200s are really not useful in this problem. Just information. For the total, okay, per, so this is density, okay? So this is per square kilometer. And what they produced is 7,704,000 pounds of milk products. All right, so here we go again. It is telling us this right conversion, you're going to put 160,500 pounds over 1 square kilometer. They want to know how many square kilometers do we use, so we'll put that underneath as x. We're trying to find that, and it's 7,704,000 pounds. So here's all the units of measure do. They teach you to keep consistency. Now in proportions, we have to put them in their corresponding places. If you're doing a science way, a little different. But so now ignore the units of measure for a minute. It's 160500 times x, and then 1 times whatever that is, right? Okay, obviously to solve for x, we're going to divide. And let's see, we get 48. So 48 square kilometers. All right. Some of those you probably would have figured out without this kind of proportions. You know, you would have known to divide on this one. You might have known to multiply on that one. But we just try to make sure that there's a process so you're not ever doubting whether to multiply or divide. All right, let's see if we can get one more in before the 10-minute mark here. So what we have is 27 people, all right, skated in a skating rink. Okay, each producing 2,400 BTUs, okay? So now that makes a big difference. While listening to an hour, okay, maybe there's more to it. It didn't say how long they were there for. So what they do give us is the skating rink approximately, I'm sure, is a rectangular prism. They didn't say that, but let's assume it is. So the first thing I'm going to do is I'm going to get the volume. And assuming it's a rectangular prism, you can use this formula. So 90, 40, 20. What do we got there? It's probably 7,200, 72,000. And that's going to be cubic feet. So 7,200 cubic feet of space. Now remember, you might go back to this idea of stuff over space if you like that, you know, for density. So we'll see what happens here in a minute. Now, how much heat is being produced? What you have to remember is there's 27 people each producing that much. So that is going to be, it looks like 64,800. Okay, so we're producing 64,800 BTUs. All right, now here's what's great about this. They tell us exactly how to arrange it if you pay attention to units of measure. They want cubic feet, or I'm sorry, BTUs per cubic feet. It means they want BTUs over cubic feet. Okay, so they're kind of telling us the prescription of how to do it. So that is density 2. So we're going to say we want 64,800 BTUs over 72,000 cubic feet. Okay, that's going to be our density. You know, they're telling us that that's what they want. And when we calculate that number, we get 0.9. They wanted to the nearest 10 or 1,000th, so that's why they wrote it this way. Okay, so it's BTUs per cubic foot. All right, so there it is. And we're approaching that 10-minute mark, so we'll stop and we'll pick up and do a couple more another time. Thanks for tuning in.